Hello students, the problem in our hand is to convert a decimal number to its binary representation. We need to write a program for it. The number has to be taken from the user, and then we need to represent, we need to display the binary representation of it on the console. So here we can use the division method by 2, in which case the remainders in the form of 0 and 1 can be displayed on the console, but the problem there would be that the remainders would be produced in a reversed fashion. So first of all, that remainders in case of division method are to be stored in an array, and after the conversion is finished, the array has to be displayed on the content of the array has to be displayed on the console. But we are for this code, for this program, we are not going to use the division method. Rather, we will be using some bitwise operators to accomplish the same task, that is to convert the binary number to its binary representation and display it on the console. So first of all, we would discuss the algorithm, and then we would go ahead with the code. Now, how does a decimal number is represented by a compiler, stored by a compiler into the memory? So a C compiler stores a decimal number, in its 2's complement form. So the representation that is used by a C compiler is 2's complement form. A positive number's 2's complement is same as its binary representation. Say 3 has to be stored by the C compiler on memory, then it would be stored like this. So 1 1 is 3, and it's preceded by a string of zeros. So if it is a 16-bit compiler and it uses 2 byte space to store an integer, then 2 ones and preceded by 14 zeros. So like that, 3 would be stored, and as 3 is a positive number, its 2's complement representation is same as its binary representation. Now a negative numbers 2's complement representation is like that. First of all, the absolute value of the negative numbers binary representation would be calculated. So absolute value of -3 is 3, and that's binary representation is this, and 3's binary representation is this. Now from here, to get the ones complement, would invert the bits. If it is 1, then we would put a 0, and if it is 0, then we'd put a 1. So this is the ones complement of 3. Now to get 2's complement, on ones complement we would be adding a 1. So 0 plus 1 is 1, then 0 followed with 14 ones. So this is 2's complement representation of -3, and this is how a 16-bit compiler would store -3 into memory. If it is a 32-bit compiler, then the storage space that 32-bit compiler um, stores integer value is usually 32 bits. So there the representation of -3, or the storage of -3 would have 0 1 as its least significant bits, and then preceded by 30 ones. So this is how an integer is stored by a compiler into the memory. Now for the purpose of our algorithm, let us consider a hypothetical compiler which stores a decimal number into memory using 8 bits. So integer would be stored by this compiler, hypothetical compiler, by using 8 bits or in 1 byte. Now so 3 would be stored by this compiler like this, uh, 1 1 preceded by 6 zeros. 3 3 6 bits. So this is how the number 3 would be stored in the memory by this hypothetical compiler. Now to display this binary representation from memory on the console, um, we cannot use printf statement, because printf statement actually treats this value as a whole. It cannot see the bits of the storage, bits that are stored in the memory. It would see it as a whole. And if we write printf %d, and let's say this binary value, this integer value is stored in a memory location which we are calling as variable x, then if you display x, then on the console what would be displayed as 3. So a printf statement cannot see the bits of the integer that is stored in memory. So get the bits from the memory, and to display it on the console we need to use bitwise operators. So here we would be using some bitwise operators like bitwise and bitwise right shift. So how the bitwise AND would be used is that we would be using a mask. So mask is a bitwise binary pattern. So the mask that we would be using, initial mask that we would be using is this. It would be of 8-bit size, where the most significant bit would be 1 and the rest of the 7 bits would be zeros. And the rest of the 7 bits would be zeros. So this is the mask that we would be using, and a bit mask is nothing but a binary pattern. So this is the pattern that we would be using. So initial binary pattern or initial bit mask that we would be using is 1 followed by 7 zeros. That is nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4, 5, 6, 7. So the value of this bitwise, this bit mask is 2 to the power 7, that is 128. Right, so 2 to the power 7 is the bit mask that we will be using. Now, so this is x. Now what we are going to do is, so let me maximize it, and we will be writing the algorithm now. For I, as there are, so let me not write a for, while, let me keep it as blank. We would find out the solution, find out the condition at which this loop would stop. So let me keep it blank for now, and let's see what would be there in the loop. So mask is initialized with initialized with 128, that is this binary pattern, 1 followed with 7 zeros. Right, now the statements inside the loop would be looking like this: x ampersand mask, if it is equals to 0, then print a 0. else print a 1. And after that, after this if block, just right shift the mask by 1 bit. So the mask is right shifted by 1 bit. Now what is happening over here? Let us analyze it. So say if the number is 3, that is 0 0 0 6 zeros followed with 1 1, and if it is bitwise ANDed with this mask, what would be the value? So x ampersand 1, x ampersand mask, what would be the value we would get? So we would get 1 binary bitwise AND with 0 would give us 0. 1 binary ANDed with 0 would give us a 0. Similarly, all the bits in this value is 0. So if we are binary ANDing it, if we are ANDing it with the corresponding bit of the mask, then what we are going to get is 0. So all bits of this operation would be 0. The result of this operation would be all zeros. So the value of all zeros is definitely 0. So this condition would get satisfied and a 0 would be printed on the console, right? So this mask, bit mask, what it is trying to do is to see that whether there is a 1 at this position or not. So rest of the bits, as we are doing a bitwise AND, rest all the bits would be set to 0, and then at the last position, if there is a 1, only then the value would come out to be something other than 0. But here, as we see that the last bit, the most significant bit is 0, so and the rest bits of the mask is 0, so the value is coming out to be 0, right? So the first bit that would be printed on the console is 0. Now the mask would be shifted by 1 bit to the right. So after this operation, the mask would look like this. The mask would look like this: 0 1 followed by 6 zeros. So 0 1 followed by 6 zeros. 1 has got shifted to right by 1 bit. Now all the bits apart from the second from most significant bit is are zeros, so every other bit would set to 0. Only this bit, if it is a 1, then x ampersand mask would come out to be something non-zero. But here as the second bit is 0, so the operation x ampersand mask would give us a value 0. Again we would print a 0. Similarly, for next iteration, the mask would become this. Again the third bit of the number is 0, so again we would be printing a 0. Likewise, up to this position, all the bits would be printed as 0 on the console. Now when the mask, after this 6 steps are over, on the 7th iteration, what would happen is the mask would get this value, that is 2. So 0 0 0 6 zeros followed with 1 and 0. Now when this mask is ANDed with this value, what we would get is all the bits apart from this second bit would get set to zeros, because mask has got zeros in every other place and it has got a 1 over here. Now 1 ampersand 1 would give a 1, right? And overall value of the number result would be 2. X ampersand mask would be 2, which is not equals to 0. so the else part would be executed and a 1 would be printed on the console. Similarly, in the next step, when the mask becomes 0 0 0 0 0 1, then after ANDing this mask with this value, uh, the result would come out to be a non-zero because we have a 1 at the least significant position. So again a 1 will be printed. So we can see that the binary representation that is held in the memory, by this method we are able to display it on the console. Now let us go ahead with writing the code. Now one more thing, that we have considered a hypothetical compiler which represents a number in 8 bits. That's why the initial value of mask was considered to be 2 to the power 7. That is, if the number is represented by 8 bits, the mask would be, initial value of the mask would be 2 to the power 8 minus 1, that is 2 to the power 7. If a 32-bit compiler is used the way that we are using currently, then the integer values are represented by 32 bits, usually using 32-bit storage space. So for that, the initial value of mask would be 2 to the power 31. 2 to the power 31. Now what is 2 to the power 31? 2 to the power 31. So this would be the initial value that we should be using for the mask. So let us first define unsigned integer variable and set its initial value to this number, which is 1 is in the most significant bit followed with 31 zeros. So this is how the memory image of this mask would look like. So this is the initial value of mask. Now we prompt the user and get a number from the user. So for that we are declaring a variable. We prompt the user to enter a number, and then get it from the user by using scanf function, ampersand num, that is address of the variable in which we want to store the user input. So one thing we forgot to talk about is this condition. So the condition at last, if you see that after right shifting, after this last bit is displayed on the console, then we are right shifting the mask. Then after right shifting, what would happen is this one would go off and all the bits of the mask would become 0, and the decimal value of the mask would then be 0. So the condition at the while loop would be until the mask becomes 0, this loop would go on. So this condition would be used over here. So now let us implement it. While mask is greater than 0, we would keep on looping. Now at the beginning of the while loop, we have a if condition where we are using binary AND operation between the number. So here the variable is called as num and mask. If it returns a 0, then we are going to display 0 on the console. Else we are going to display a 1 on the console. And after this if block, we are going to shift the mask by 1 bit. After that, let me give it. So we are done with our code. Let us run it and see whether it is working fine or not. So I missed a semicolon over here. So it is compiled correctly now. Let us run it and try to display the binary image of 3. So binary representation of 3 is coming out to be correct. 30 zeros if you can count it, then followed with 1 and 1. What about binary representation of -3? As I said, that a negative number is stored in the memory in 2's complement form. So -3 is 31s followed with 0 1, right? In our discussion also we found this out. So we actually talked about 16-bit compiler, in which 16-bit is used by the compiler to store an integer value, and -3's representation was 14 ones followed with 0 1. Now here we are talking about we are using a 32-bit compiler, so 30 ones followed with 0 1, which is correct. So our program is working correctly. So with that we have finished the code, and we have learned to use binary AND operator and binary right shift operator, and we see that by using this bitwise operators we can actually go down to the bitwise level, which is not possible by using a printf statement or any other operator, plus, minus, into, divide. This is only possible by using bitwise operator. Okay, so in our next sessions we would deal with more problems in C, which would help you to um, prepare for your exams, entrance exams, or for your interviews. So keep watching. Thank you.